you use the symbols for the elements.
Does this still go under the molecular compounds, or is this by itself?
This is new. That's all the information we just talked about. We're going to use that to talk about how to draw Lewis structures. That's when you take water. Water is H2O, and you draw the two hydrogens and the oxygens, and you show how they're bonded to each other, using lines and maybe dots if necessary. So let me give you some rules for drawing Lewis structures. And these rules are kind of in your book on page 314. I tend to give you my own set of rules, but you can look at page 314. It'll go along with this. Okay, the first rule for drawing Lewis structures is to add up all the valence electrons. As we go through these rules, I'm going to flip back and forth between two slides. On this slide, I'm going to apply the rule to something. If I said carbon tetrachloride, y'all should know what that formula is. What is the formula for carbon tetrachloride?
CCl4.
Carbon tetrachloride is CCl4. This is the compound we're going to use to apply each of the rules that I give you. Okay, this will be our practice one. So what does this rule mean? Add up all the valence electrons. Well, guys, in carbon tetrachloride, y'all know that there's one carbon and there's 4 chlorines, right? I can look at the periodic table, and from the position of carbon, I know it has how many valence electrons? Carbon has 4 valence electrons. From the position of chlorine, I know it has 7. So that's a total of how many electrons? 32 electrons. Does that make sense?
Yeah, it makes sense.
Okay. That's rule 1. That's what it's saying. What does that number mean? Guys, we've got to use 32 electrons. Either with dots, each dot counts as 1, or with bonds, and each line counts as 2. You have to use 32. You can't, it's not a good deal to save and only use 30. That's bad. You have to use 32, no more, no less. The second rule. Sketch the molecule. The more you practice, the easier this will be. When I say sketch the molecule, in other words, we're working with carbon tetrachloride. What do you think is going to be bonded to what? Okay? Do you think you're going to say carbon, chlorine, 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 chlorine?
No.
No. What would you draw?
Put carbon in the middle.
Okay, y'all want to all put carbon in the middle and then chlorines all around it? Why would you do that? Because that's what it is. Can I tell y'all that when you ask me why? Because that's what it is. I mean, it's a hard question to answer, isn't it? How come you draw it like that?
Fill an electron for each chlorine.
Okay. If we think back to way over here, we said chlorine would typically form one bond, didn't we? Because it's got one dot by itself. Now, we don't have carbon up here, but which one of these would carbon fit? Since it's in group 14, carbon would fit right here, yes? How many bonds can it have? It can have 4. So then if I just remember that, of course, maybe that's overthinking it for you. Maybe you just said CCl4. Well, since there's only one carbon, it just makes sense that it would go in the middle. And that's okay to think like that as well. If there's just one of them, that's probably the one that goes in the center. Okay? So that takes care of rule 2. Any questions? Well, that's going. Who said that? Yeah, we got to go to rule 3. We're going to do it one step at a time. Okay, rule 3 says, satisfy the octets. What does octet mean? Means 8, doesn't it? Satisfy the octets of all atoms bonded to the central atom. Satisfy the octets of all atoms bonded to the central atom. Can I flip to the next slide? Or stay here a minute? Okay. Here we go. Y'all, this rule, step 3, is applying to the chlorines. Right now, each chlorine has 2 electrons. Because each chlorine has 1 bond, and we said that bond is 2 electrons. So right now, each chlorine has 2. In order for each chlorine to have an octet, how many am I going to have to add to every chlorine? I'm going to have to add 6 more. So that's where I'm going to put my dots around my chlorine. Now that chlorine has an octet. It has 8. And I'm going to do that for each chlorine.
Why does it have 2 already?
Yeah, I was going to X that.
This bond, I'm going to not do this one. That bond is 2. That means that chlorine has those 2. Okay? In order to have an 8, I've got to add 6 to that.
So it'll always be 2 before you start?
Yes. Okay. Not, well, if there's 1 bond, it has 2. To further kind of let y'all see the 2, look at carbon. This is good. We're going to look at this in a step in a minute. Carbon also has an octet. Do you see it? Look at the bonds around carbon. 2, 4, 6, 8. Carbon has an octet as well. Excuse me. The octet rule says that atoms will gain, lose, or share electrons. So in each one of these bonds, carbon and chlorine are sharing those electrons. In sharing them, that makes chlorine satisfy the octet rule and carbon. So when you're counting octets, you get to count the bonds twice. You get to count them for the chlorine and you get to count them for the carbon when you're counting up octets so that everything satisfies it. Okay?
So like chlorine has 7.
All right, guys, here's rule 4 or step 4, however you want to look at it.
How many rules are there?
5. 27 rules. I'm just kidding. And you need to learn them all. No. Step 4 says place leftover electrons on the central atom. Place leftover electrons on the central atom. So I'm going back to where I've been practicing this. Now we're ready to use this 32 that we started with. Y'all count in this structure, count the dots and count the bonds as 2. How many electrons do we have drawn right there?
32.
We've got 32. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32 electrons. So we've used all of them. There aren't any electrons left over. If we counted this up and it was 30, then we would put dots on the carbon.
So you'd use the Lewis dot structure for the dots around the one in the middle for the electrons?
Right. That's what the step 4 says. Okay, so as far as this structure goes, there are no leftover. There's nothing to do for rule 4. Rule 5, which we don't need on this one, I'll show you why in a minute, but just in case you ever need it. If there aren't enough electrons to give the central atom an octet, if there aren't enough electrons to give the central atom an octet, and I'm running out of room, so I'm going to have to put the rest of that rule on the next slide, then A, you can try multiple bonds. Or B, it may be an exception to the octet rule. There's always an exception. Yes. Rule 5 is not needed for this carbon tetrachloride that we've been working on. Let me point out two things you have to check. Okay, these are two checks. Y'all might want to write this down. I'm not going to write them because I've got a whole lot up here and I want to stay on this slide. Two things you need to check. Number one, does every atom have an octet? That's the first thing you want to check. Does every atom have an octet?
What is this like?
This is checking your drawing. How do I check and see if I'm right?
This doesn't count the one in the middle, does it?
Huh?
This doesn't count the one in the middle.
Yes, it does. Hang on, I'll show you how to check it. There's two checks. Number one, does every atom have an octet? Guys, look at this. This chlorine has an octet. Do you see that? Yes. 2, 4, 6, 8. This chlorine has an octet. 2, 4, 6, 8. This chlorine has an octet. 2, 4, 6, 8. This chlorine has an octet. 2, 4, 6, 8. And finally, this carbon has an octet. 2, 4, 6, 8. Okay? So rule number one checks out. Does every atom have an octet? The second thing you need to check, did you use all the electrons? Did you use all 32? No more, no less.
So then when you said, when you put leftover electrons
Uh-huh.
on the one in the middle, how would that affect it if it's already out?
If it's already an octet, you cannot put more electrons on it.
Okay, so
That's going to that's going to take step 5. You're going to have to do multiple
the only
bonds.
way for you to put it extra ones in the middle is if it's more than 52.
No. You just hang on and we'll do some where you've got to put dots on the middle. Okay, so the second check was, did I use all 32? Did I? Yes. Guys, if the answers to both of those questions are yes, then that is very likely the Lewis structure. You've got it right. If the answer to one of them is no, that means you have to fix it. Okay, that means it's not right. You want to fix it.